So today, I'm super proud to announce ROCm 7. ROCm 7 is bringing exciting new capabilities to address these emerging trends and brings support for our MI350 series of GPUs. It continues our relentless focus on usability, performance, introduces the latest algorithms, advanced features like distributed inference, support for large-scale training, and new capabilities that make it easy for enterprises to deploy AI effortlessly. Within ROCm 7, inference has been the largest area of focus. We've innovated and invested at every layer of the inference stack, from the latest framework enhancements in VLLM, SGLang, implementing serving optimizations, supporting advanced data types, to delivering extremely high-performance kernels, to implementing the latest algorithms like flash attention v3. We made it easy to author and integrate kernels with Pythonic abstractions, and we've done significant work in our communication stack. This is how ROCm 7 delivers over 3.5 times the performance of ROCm 6. And when it comes to inference serving frameworks, it's becoming more and more clear that open source feature velocity and performance is in fact outpacing proprietary alternatives. Just look at what's happening in frameworks like VLLM and SGLang. They're actually setting the pace on commits and have both enabled FP8 optimizations and support ahead of closed alternatives. Working closely with these open source communities, MI355 is today delivering up to 1.3x better throughput on DeepSeek FP8 when compared with B200. That's the power of open collaboration, moving fast and delivering more. One of our earliest partners that's innovating at scale with ROCm is Microsoft. So to talk about our work together, please join me in welcoming Eric Boyd, CVP AI Platforms from Microsoft. Hey, Eric, so good to see you. Thank you for joining us this morning.
Yeah, really glad to be here.
Yeah, we have been very close partners for a long time. Can you tell us a little bit about how that partnership has evolved, and particularly around Instinct?
Yeah, sure. I mean, as you know, we've been using several generations of Instinct. It's been a key part of our inferencing platform, and we've integrated ROCm into our inferencing stack, making it really easy for us to take and deploy new models on the platform.
That's great. Now, tell us a little bit about the type of models, what kind of work our teams are doing together.
Yeah, so at Microsoft, the customers that come to AI Foundry or even our internal customers are looking for the cutting-edge leading models. And so models like GPT-4o or 4.1 from OpenAI. And the Instinct chip really gives us great performance on top of that platform, really enabling us to scale and perform at the tremendous scale and low latencies we need.
That's great to hear, and we've been super lucky to have collaborated with your team over the years. Tell us a little bit about the role AMD plays in enabling performance, efficiency, and what flexibility does it provide in your infrastructure?
So when you're serving these large language models, one of the big challenges is taking advantage of all of the memory on the chip. And so the models have tons of parameters, and they have caches and things. And so the more memory you have available and the better bandwidth, the better performance you get and the better latency that you get out of it. And so the Instinct chip brings a large memory footprint along with really dense compute across it. And that all combines to give us really great TCO benefits as we use these chips to serve our platform.
That is so great to hear, because that's exactly how our engineers have been thinking about it when designing these features.
They did a good job, yes.
And you've expanded from the original set of models now to actually working with more open models. So can you share a little bit more about the work there?
Yeah, of course. At AI Foundry, we're committed to making sure customers get the most advanced models from OpenAI, Mistral, Cohere, other companies like that. But we have over 11,000 models in our catalog, and most of those are open source. I think one of the interesting things over the last few months has been the emergence of DeepSeek, as an open source model that provides really great quality in it. And we inference the DeepSeek model on SGLang, which is an engine that's open source that we've contributed to, adding things like predictive sampling and the like to it. And being able to use that sort of open source framework has really accelerated the development in this space. And of course, ROCm's integration with open source makes all of this really easy for us to deploy at scale.
Yeah, that's been so refreshing, all the work that we've done in the open. Now, as you look ahead, you've again expanded the footprint of activities, and now we're looking at training. So that's super exciting. So maybe share a little bit about what we're doing there.
Yeah, it's really interesting. As we look forward, we've seen such tremendous growth in inferencing, and we don't see any signs of that slowing down. And the Instinct looks to be a key part of our platform on inferencing going forward. But it's also great that it works really well as a training chip. And so we've been able to train, on 2100 MI300Xs, a state-of-the-art multimodal model in our research team. And really being able to use the same platform for inferencing and for training gives us tremendous flexibility in our data centers. And as we look forward, we're really excited to continue partnering with AMD on our inferencing and our infrastructure solutions.
That's awesome. And actually, this afternoon, there's more information. There's actually a nice talk on the work around training. So I encourage you to go hear about that. Thank you so much, Eric. It's been great having you, and wonderful
Thanks so much,
partnership
Vamsi.
here. Microsoft has been an incredible partner, right? With at-scale deployments, running everything from closed-source GPT models to now open-source DeepSeek, and extending the work now to large-scale training. So talk about training, it's an increasingly important area of focus for us, and ROCm is making big strides there too. ROCm now supports all major parallelism strategies with functionality across major frameworks and libraries, including PyTorch, JAX, TorchTune, and TorchTitan. And look, we're just not enabling models, we're also building our own. Training on ROCm internally at AMD is helping us improve performance, reliability, and the developer experience. And just like inference, training performance has also taken a big leap. ROCm 7 delivers 3 times the performance of ROCm 6. More importantly, our users are actually telling us that they're now scaling confidently with ROCm